let's just start. I'll just share the screen. Today's lecture is gonna be a lot of more interesting than the previous lectures, because today it's gonna be a little bit of different things and complex, and there is gonna be some complexity, but yeah. So just imagine you're working on a desk or your office desk, that is your office desk. So you're just working on it, and you have a lot of papers surprisingly on your desk, and that's a lot of paper. So you have exhausted the space on your desk with all the papers kept side by side. So you don't have more space to keep more papers, and there is an ant here. So this is a caricaturous ant. By the way, this concept is I've taken this from the lectures of Mr. Neil deGrasse Tyson, who is a renowned astrophysicist. You can watch his lectures if you want. They are great. They are an amazing resource. So here is an ant who is just lying there, and she lives in the world of two dimensions. So she lives in the world of three dimensions, but she feels like she's living in the world of two dimensions because her world is the desk of the table. So the top of the table. So for her, for the ant, the world is the top of the table. So all she can see is the table as a surface down and the papers aside. So she says there is no space here. But when I bring a page organizer here, and I keep the pages one by one on top of each other, and I just organize the pages. So the ant is surprised. She's saying, "Oh, what is this? The pages just got disappear." But she doesn't know that I have transferred the pages in a third dimension, which is an extra dimension. So there is an extra dimension. So for the ant, she's imagining that there are just two dimensions. There is there is the left, right, and forward, back. So she's living in the two dimensions. She can't go up, she can't jump or something like that. So for her, even if she is climbing a wall, there's just two dimensions. She's always living in a world of two dimensions. So uh, that is to speak theoretically or for an example. So it is not a researched thing that we are saying. That is a thing that is given for an example. So she's living in two dimensions, and suddenly you take out the papers which are besides her, and you pile them up in the organizer, the page organizer. So she just is surprised. She's astonished by what has happened. The person in front of me, this giant human, has taken all the papers and just disappeared. The papers have disappeared from my sight. So similarly, if you have a room, you have a closet which is empty, and after that you put some boxes, you get deliveries, you put some boxes. In this case, it is a three-dimensional world. There are three dimensions. I'm just giving a prerequisite to all of this. Afterwards I'll just explain what the three dimensions and what for amongst you all who do not know about the idea of dimensions. So this is just a prerequisite. So you just have a closet. So you are a human. So you live in the world, the ordinary world of three dimensions. You can go up, down, left, right, forward, back. So that's all. And you fill the room with boxes. So suddenly the room is empty, and you fill it up with boxes. And you've ran out of space. You need more space to keep the boxes. You get deliveries every day. So maybe you own a big shop which needs a go down to store the boxes. which needs a warehouse. So you don't have a warehouse, you are a poor man, so you just pile them up in your closet, but now you have run out of space. So even if you keep it pile them up one by one on top of each other, you can't just go on adding the space. But suddenly a different multiplanetary species, an alien comes, and he's looking at you, he's laughing how these stupid humans are just running out of space. They are so stupid because he's a multidimensional species, he's a multiplanetary plus a multidimensional species, so he knows more dimensions, more than the three-dimensional world that we live in. So he just takes the boxes, some of the boxes he takes, and they are disappeared again. So they disappear. So the alien has just disappeared the boxes. So he has not just disappeared the boxes, but he has kept them in some higher dimension, but you can't see them. But I'll just give you one more example afterwards, in which you will get a better understanding of what I'm talking about right now. Maybe this would go above your head, but later on you will understand all this. So the alien is smart, so he's just keeping the boxes in some other dimension. Yeah. So you can also, I'll just give you one more example. So you can also just uh, imagine that you're fond of art, so you just draw arts, and if you are aware of this thing, you draw it on sticky notes, and then you just go one by one then you just go to the pages one by one. So you just have to slide through the pages so that it looks like an animation. So there's just one page which is two-dimensional. You're drawing each page in a two-dimensional space, and then you are just piling it up one by one, and in at every second there is a timeline of the pages. So you are making time as the third dimension. So I'll just explain you what dimensions mean. I'll just turn off the screen share, and I'll just you just have to look at my video. So if you take a pen, so this is one dimension. So if you want to go through this point to this point, this is just one dimension. If that is a dot, it is zero dimension. So that is just a dot. And when you extend the dot like this, you make a pen out of it. So this is a pen, and it is one dimension. Then you further extend it and you make it like this. You make it you make a perpendicular line. So this is the x-axis and this is the y-axis. So you can move through the plane. So you can move through the two dimensions. While earlier you could move through this line, just this line. So you could be here, 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 here. But in this case, you can be here, 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 anywhere on this plane. So this is a plane and you can be anywhere. So you can just imagine of this. And the next part is a little bit difficult, but to represent, but I'll do that. So these three lines will be mutually perpendicular to each other. So this is the x-axis, as we said earlier. This is the y-axis, and there is one more axis that is the z-axis. So you can now be in any space here. So you can now be anywhere. So I can just define you by three coordinates, just 3 points. So if you know the coordinate system, if I'm 1 unit to the x-axis and 2 units to the y-axis, I'll define this point by 1, 2. I'll just show you on a whiteboard. Yeah, so this is a y-axis, this is an x-axis, and this is a straight line, by the way. I'm just not so good at drawing. So this is an x-axis and this is a y-axis. They extend to infinity, and yeah, so these are two dimensions, so you can just go here, here. So when you go to the minus side of y-axis, it will be denoted by -1, -2 units, -3 units. So right now you are just at -1.5 in the y-axis, and just at 1, 2, 3. So you are at 3 comma -1.5. So these are your coordinates according to the plane. So if you want to go this side, you can also go this side. So there are 4 quadrants here. You call it as quadrants. This is the first quadrant. This is the second quadrant. So you will learn this in maybe high school, because or you may have learned this already. All of this will come in SAT too. So in the SAT prep also, you'll SAT, the standardized prep. Yeah. So yeah. So this will be if there is a dot here, so this will be just 0 dimensions. So if you extend the dot, it will be 1 dimension, and you extend it further, you take the line and you push it ahead. So you push the line ahead. So now the same line is transversed here without changing the angle, and you are just joining the two lines, the ends of the two lines. And now here is your paper, here is your plane. You can be here, here, anywhere, the two-dimensional space. So I can just define you by that. So what I call this is also a two-dimensional space. So I have extended the line, and further you go, you just extend all of these ends, and you make it a space, a cube. So that is a three-dimensional space. A cube is a three-dimensional space. So you just join all of these lines and you just make it a cube. Yeah, gotcha. So this is a cube right here. So you can just add an extra dimension, an extra axis to it. So I can't draw it right now, but I'll just make it an a 2D representation of it. I can make a true 2D representation. So I can make like this. So this is an this is an a Z axis. So the Z axis is coming forward. It is coming out of the screen, out of your computer screen, and it is going backwards from this side. So this is a Z axis. So this is a three-dimensional space. But what if there are extra dimensions? So do you believe in extra dimensions is the question I would like to ask you. So just put it in the chat box if you believe in extra dimensions. Do extra dimensions really exist? Just put it in the chat box. Yes, this is just a thought, but since the line is the same as infinite dots next to each other, isn't it still 0 dimensions? Yes, it is a 0 dimensions, but it is infinitely when you uh, make dots side by side, it will make a dimension. So you can be at any dot. In 0 dimensions, you can be at just one place in the in anything. Yeah, so you can be at just one dot. But when you talk about one dimension, you can be at all those dots. So you can be at one of those dots. So yeah, tesseract is a thing that we'll discuss afterwards. This is a trick question. So what makes that makes sense? Yeah. So it is the same. I'll just go back to my blackboard, whiteboard, sorry. Yeah, so this is my whiteboard, and so this is a dot, this is a dot. So these are infinitely many dots connected to each other, and they make a line. But that is what that is the core concept of what makes a dimension. So if you just make infinitely many lines by side to each other, so it will make a shaded square or a rectangle, right? So that will be a plane, that will be a two-dimensional object. And when you join infinitely many rectangles side by side, that will make a cuboid or a cube. That is the idea, the core idea of dimension. So uh, so you're arguing on a thing that is the idea of the concept. So you're right, yeah. So it will be infinitely many dots which will make one dimension, and infinitely many lines, it will make two dimensions. Infinitely many planes, it will make this is called a plane, by the way. So you can be at any point in this plane. So this will be a plane, so you can be here, here, or here. Yeah, I'll just make a smiley. You can be at any place here, and I can define your position. So this is a plane, and you when you I can give you one more example. If you take two just imagine that the two dimensions that I'm talking about, the rectangle that I'm talking about, is a paper. Although paper has some thickness, but it is negligible. Just neglect the thickness of a paper. So you can just imagine that a paper is a two-dimensional object. It is a two-dimensional shapes. And when you pile up too many papers like this, you pile up too many papers, so they make up a three-dimensional space, right? They make up a three-dimensional rectangle. So by the way, these are many papers, the thickness is added up, so the thickness is integrated. Yeah. So this is a pile of papers, and it is making surprisingly a rectangle, a cuboid. So this is making a cuboid. So if you just look at it from another side, or the papers are somewhat transparent, they are just plastic sheets or glass sheets, then you can just see those papers like this. So they will be a cuboid. So and they will be stacked like this. So that's also this is the idea of dimensions which I was talking about. But I was asking the question, are there extra dimensions, and if there are, what are they? What can you describe as an extra dimension in your own words, or in your world of three dimensions? Yeah, you think there can be more dimensions, more than three dimensions. I too think that, and most of the physicists do think that there can be extra dimensions. There are, in fact. Einstein theorized that there are extra dimensions, and there is an example that I would like to give you right now. So you got this example. So this is a, if you're familiar with this thing, this is a sticky notes thing, and you're drawing on it, and you're making just an animation. You can make a whole movie of it. So the concept of video works on this concept. So the whole idea of video making or videos work on this concept. So I'll just tell you one example from your daily life. So you are all fond of taking photos and putting it on Instagram. So what are these photos made of? So they are just tiny pixels. If you just zoom into each and everything, so these are just dots. So this is one dot, these are two dots, these are 2 pixels, so 3 pixels, 4 pixels. So these are 4 pixels into 4 pixels, so these are 16 pixels inside this. So they all make a good photo. And you can think of it as the 1 pixel as one dimension, and it is turning into 2 dimensions. So this is a fact that I think personally is amazing, because physics is integrated with everything. The physics is explaining the concept of video making. So in video making, you can think of a video as a higher dimensional thing. So you're thinking of a photo, and you are integrating lots of photos. So you are integrating what we call frames in video language. So you are integrating lots of frames. So if you put one by one photo side by side, you can see a video that is combined photos. So uh, when you talk about FPS, so that is frames per second. So the frames per second means this. So in 1 second there are 40 photos going on. In 1 second there are 24 photos going on. So these photos are the frames that are going on. So you can talk of it as a higher dimensional thing. So yeah. Okay, so when you in this three-dimensional world, when you want to address a star maybe, so how do scientists or physicists, just astrophysicists, just address a star that is, or the position of a star that is in sky? So how do you address the position of a star that is high in sky? So this is the coordinate system that they use. So there is the zero or right ascension, there is an equator, and here is our earth. If I zoom into it a little bit, yeah, so here is our earth, and this the radius of the outer globe can be determined by anything. So you can just generalize it. The radius will be the distance between the star, but we take generally take the earth as as the origin of the graphical representation. So I'll not get into the depth of this, but just it is a good thing so to know, because you just use it to calculate the position of stars. Yeah, and by the way, this is a tesseract. I just told you that when you extend a dot into a infinite number of dots side by side, you make a line out of it. You integrate the number of lines side by side. You make a, a two-dimensional space, that is a rectangle, or a square, that is a rectangle. So when you make it a cube, and after that the latter stage of that will be a tesseract. So this is a tesseract, this is a four-dimensional cube. So this works in a very different way than you think, but I can't right now I can't show you the video part of this. But when it is moving, it looks a little bit weird to us, because we are used to the seeing the world in three dimensions. Also, I just want to tell you one ideology that I think okay, so I'll just show you representatively. So I'll just share the whiteboard. Yeah, so I'll just clean this. So there is a book called Flatland: The Romance and Dimensions, or something like that. The name is like that. So it is a book by Mr. Edwin Abbott. So you should give it a read, give it a try. So that is a book that I read recently, and I thought it is good to add it in this portion, this curriculum, because I think that is a very helpful resource in this. Because if you look at the book, it talks about a village where people, all the people that are there live in the world of two dimensions. So there is a square, an uncle square. So he has his eyes here. So these are the eyes. Just shade them. Here is these are all geometrical shapes, but my drawing is not good. So you may look at it. So these are the eyes of Mr. Rectangle, Mr. Triangle, and here is a Mr. Rectangle, his eyes. Here's a Mr. Circle. So all of these people, if you see, they are all living in a world of two dimensions. So what do you think will be their line of sight? So our line of sight, we have a little bit of depth perception too, because of our two eyes. So you can see that there is some depth to a glass of water kept in front of you. So it is not a two-dimensional glass of water, it is a three-dimensional. You can tell that by the depth perception you have. Some people do not have the depth perception, and that is a disorder. But yeah, most of us have. and so these people do not have depth perception because they are living in a world of two dimensions. But as a three-dimensional creatures, humans can see their sight in two dimensions. Don't you think so? So if you capture a photo, that is a photo that tells us about a three-dimensional world in in two dimensions, but it matches with our sight. So I'll just ask you, what is your guess? Would these people look from their line of sight? So this is their line of sight. This is a straight line, by the way. So this is his line of sight. So he's looking at the triangle. So what is your intuition? What will be the line of sight for the Mr. Square when he looks at the rectangle, a little bit of rectangle here, and Mr. Triangle in the between? So what will be his line of sight would be? I'll just ask you in the chat box. Yeah, you can answer in the chat box. Yeah, this is how they that was how they calculate the position of things in space. They also use the parallax method, where they use the Pythagorean theorem. They just calculate the angle between the star, that the line of sight, the angle of sight which we see from Earth, and they wait for 6 months and then they do that. I'll just show you that. I think that is fascinating for you all. I'll just show you that. I'll keep this aside. So they just this is Earth. I'll not go into much depth of it. So this is the sun, and this is the Earth, and this is the orbit the Earth is following. It is a celestial orbit. Yeah, and these are the two positions at which Earth will be. And this is position A, and this is position B. So, and this is a distant star that is there. Okay, I'll draw it this side. So this is a distant star, and you calculate the line, the angle of line that is there. So this is, I'll just extend the line. So you calculate this the angle. So you calculate the angle, and the next year also you calculate the angle. Not the next year, it is 6 months after. So yeah, so you just calculate this angle, and this angle, and you already know the distance between the sun and the earth at that point of the year. So you calculate this theta and this theta 1, theta naught. Okay, so and then you get the distance between the sun and the star. There are complicated, this is not as simple as it looks. There are complicated equations to it, but let's just now get to the point of the line of sight of the flatlanders, the people of flatland. So just put it in the chat box what you think would be the line of sight for the flatlanders. I'll just wait for someone to answer. Could they see depth? There is no thing called as depth in the world of two dimensions, because there is just a plane. There is just a plane. I'll just answer after one or two of you answer the question. Try to answer the question. No, they will be able to see each other. A flat triangle side. No, but no, they'll not see a flat triangle side. They will not see shapes or anything like that. I'll just tell you now. So these are the flatlanders again. Yeah. So these are the flatlanders. and the site that they see. So say this is the site. They will see a site that is one dimensional, because as we are the three-dimensional species, we see a site that is two-dimensional. Just there is an extra thing called depth perception, but keeping that aside, depth perception is when you move, but when you are stable, it is all a picture. So it is all a picture. If you're not moving and you still see at your laptop, and I'm sharing the screen, so that will be a kind of a picture. So you can't say that it is a three-dimensional world. So from your eyes you can just see two-dimensional world. When you see a cuboid, you just see the one side of a cuboid. So when you see a cuboid, if the cuboid is kept like this, so you don't see the back side, the back part of the cuboid. You just see it as a square or a rectangle. You just see this side. So you don't know if it is a cuboid or a square, because you have a line of sight that is one less dimension than what world you are living in. So we are all prisoners of three dimensions, but our sight is of two dimensions. So for the flatlanders, surprisingly, their sight will be intuitively, it will be just one dimension. So here is the triangle, which is blocking the light from one side. So this is a triangle, and this is the rectangle side that is coming in between. So there will just be light and no light. So there will be just portions of light and there will be portions of no light. So this is the side. So here it will be dark, the shaded portion will be dark, and from here it will be nothing. If there are distant objects, there are distant something, so that they will appear just as shaded portions. So that is a little bit boring. But what if a sphere, what if a sphere came into the picture? And a sphere is a multidimensional species for them. So a sphere will be three-dimensional species. So a sphere came into their lives, and he's just going from their line of sight. So let's just imagine their line of sight seeing a sphere, because that is a new thing they are seeing. That is not a thing that their brain is capable of handling to. So for a sphere, that will be a magical object for them, because their line of sight will change constantly. A sphere is a three-dimensional thing, so three-dimensional space. So first the square will see just this part. So the sphere is like this. I'll just draw a sphere. Yeah. So this is a okay. So this is a sphere. I can't draw it in three dimensions because my whiteboard is not capable of that, of the depth perception. The depth perception is a thing that gives you the feeling of three dimensions. Otherwise, you're just living in a world of three dimensions with a sight of two dimensions. Yeah. So the first side, sphere sees the Mr. Square sees just this part of the rectangle, just this thin line. So it is just blocking his sight in this way. So it will be just this, and then later on he will see a bigger shaded portion, which will be this. So but he is missing the part that the sphere is a complete sphere, and he's just seeing it one by one. So this is a sphere, and it is, I'll just draw it one more time because it will be difficult otherwise. So this is the line of sight at first second, and the second t equals to 1 second and t equals to 2 seconds. So in first second the sphere will be just this much. On the second the sphere will be this much. So that is actually the whole sphere, but the Mr. Square can't comprehend it at once. So he's seeing it one by one. He's scanning it. So his scan machine is going from up to down, but he can't comprehend it as a sphere. So he's just seeing one by one. He's seeing lines of it. So that is the that is the site of any person in the village of Flatland. So yeah, I'll just give you one more example. Any comments or anything, I'll just read it once. You can draw a curved line through the middle and a dotted line in the opposite direction. I don't yet understand what you're trying to tell. Please just tell me. You can draw a curved line through the middle of a dotted line and the opposite direction. To make the sphere look like it's 3D and has depth. Okay, so you can draw a curved line through the middle. Yeah. I got it. So you're talking about this to make it look like 3D, but that will be just the representation of it. It will not be the. But as long as you are understanding it, once I draw it as a circle, it is okay, now. Yeah. So I'll just draw it. What Olivia is telling me. So she's trying to say that just draw a dotted line from here. So this is a sphere. Okay, I'll just take a good sphere. Can't just rely on my drawing skills. So the longitudes I have to draw, right? Like an orange peel. Yeah. But yeah, so this is a sphere and this is the same as this thing right here. But as did you understand the thing that I taught right now, the site of the Mr. Square and this part, that he sees the triangle as just a shaded portion that is blocking the light coming into his eyes, and he scans the circle one by one. Just tell me in the chat box. Yes. Okay. Yeah, you can ask me right now. If you have any questions, it's okay. Okay, should we proceed ahead? Yeah, so I'll just give you one more example. Thanks, Aarti. Yeah, so I'll just give you one more example. So we proceeded from the tesseract. This is a difficult shape that you will have difficulty in comprehending when you see the. I'll just show you the movement of the tesseract. Right now, it will be difficult for you to comprehend the movement, but then too, I'll just show you. Yeah, so this is what it will look like when it is moving, when it is rotating. When you see a cube that is rotating, so this is a tesseract that is rotating. It will look a little bit weird, but it isn't fourth dimension. So you just can't. Your brain is just used to the world of 3 dimensions. So this is a legit representation of it in 3 dimensions. because it has some depth, and it is just compressing the dimensions. Yeah. Yeah, it's confusing because your brain is just used to the world of three dimensions. Let's just go ahead now. Okay, so Einstein theorized that time is also a dimension. So do you agree with that? Because don't just agree because it is Einstein who said that, but what do you think about the fact that time can also be a dimension? Because uh, time is an amazing thing, because as we discussed in the earlier class, time is not an absolute thing, but it can be an absolute thing with the idea of entropy. So yeah, just tell me, what do you think about the fact that can also be a dimension? Because right now you are just familiar with the things that there are dimensions in space, but what about time? Yeah, it's a direction of measurement, but I doubt that's the fourth dimension. I'll just give you a comprehensible example. When you call someone for a meeting or somewhat like that, you give the coordinates of the place. So you just tell him that come at the Times Square, or come at the Eiffel Tower, come near the Eiffel Tower, or come at this place in New York, this place in Washington. So you just give the location and the time. So time acts as a fourth dimension. So you give the three axes in space and one axis in time. So that is little bit uh, a little bit intuitive example of why time can be the fourth dimension. So there is the location, but we personally are the prisoners, I can say, the prisoners of three dimensions. So we can just move through one direction in time. So when you see at all the dimensions, there are various directions to that, but in time dimension, if you see time as a dimension, so there is just one direction that we are moving through. So yesterday someone asked me, can you travel through time? So I said yes, because I yesterday traveled through time at 1 second per second, and I just traveled 24 hours yesterday. So I just traveled from past to the future. So that is a cool thing to say. uh, yeah, so uh, yesterday was not a class. Someone from another world asked me, an alien asked me, can you travel through time? Because we do. Yeah, so that was a joke. Lol. So let's just go ahead. Yeah, so as we discussed earlier about the fabric of space time, or the space, that is the graphical representation, the graph that was there, the three-dimensional graph. It was like blue colors and all that, that we showed in the last class. There is we can generalize the fabric of space. The physicist Albert Einstein, he just imagined space to be a fabric which is flexible. So it is a fabric that can be folded, it can be bent, or it can be just elastic fabric, like an elastic fabric. So what actually bends the fabric of space? So space and time, the if we precisely say space time fabric, okay, the continuum, so that is gravity. So why do celestial objects always orbit around each other? Because if you just see an example of fabric, you can just search it on the web, space-time fabric example. So there is a muslin cloth that they show, a muslin cloth in which a heavy object is put in between. So the muslin cloth just bulges at that side, and they just put some marbles on it. They give some initial velocity to the marbles, and the marbles just keep rotating until they are stopped by friction, but in space there is no friction, so the earth is just rotating continuously around the sun, and same is happening for moon that is rotating revolving around the earth. So one more example that I would like to give is that when you see this pole, sorry for the bad quality. The bad quality is because there are not a lot of pixels there. So the two-dimensional space is close to one dimension, because that there are a lot less pixels than a 4K image. So yeah. So if you see this rod right here, what do you think, how many dimensions is the rod in? So a line, as I said, is one dimension. So uh, so how many dimensions is the rod to you? So when you see a rod, what do you think of it, as in the sense of how many dimensions are there in the rod? Just tell me in the chat box. Yeah, just tell me. 3D, 2D, 1D. It will be 1D, because for you, for a for a person looking it from far away, it will be 1D, because it is just looking at as a line for you, because it is just a line. So if you take it too far away, so it will look like a a line that is there. So but if you take it close, there are just curves to it. So yeah, the I'll just show you once again. So a normal person, when he sees the rod, he sees it as a one-dimensional thing, a one-dimensional object. A rod is just a line. So yeah. But when you go to the world of ants, it is just when you zoom into the rod, it is a circular rod. If you are if you are an ant, you will just see the rod like this. So this is an example, an animated example of an ant looking, which is situated on the rod, that you were previously looking at as a one dimensional object, and the ant is just looking at it as a circle. So it is just a circle that is three dimensional, because that is a circle that is two dimensional, sorry. But if the ant is progressing ahead, it is looking at it as a three-dimensional cylinder. So yeah, so the ant is going through it is walking through it. So this is an amazing example of how when you get near the object, you see more dimensions. You have perception of more dimensions when you go near the objects. So let's just go ahead. Many of you said that the rod is three-dimensional. You were right, and but if you practically speak, when you see a thing from very far away, you just see it as something. The dimensions that we see reduce because of the reduction in the depth perception. Because when you look at stars, so or planets which are far away, you just see them as dots. So the dots are what they are, zero dimensions. So if you just look at this image, there is a small thing here, it is a planet, and how many dimensions is there? So it is a dot, you can see it as a dot, because it is not that far away, because I have to zoom into it, because that's why I have kept it not too far away. So you can see it, many of you can see it as a circle, a small circle. But for the if it was a lot more far away, it would be seen as a dot, that is zero dimensions. So yeah. Yeah, so but when you look at it from far away, you look at it as just one dot there, which is zero dimensions. But when you zoom into it, I'll just zoom into it, and you see it is two dimensions. There are a lot of pixels there. Yeah, so you see there are two dimensions. But I'll just give a refined picture of that. So when you zoom into it, you see it is our Earth. So now what you see is a circle, and from far away you see a circle. There is some depth perception here. You can see that this portion is far away by the size of it, or by the size of the land masses on it, or by the shadows on it. But normally you can see it as a circle. Now if you go more into it, if you go ahead, and you just go into it, you just jump into it, you just dive into it, you just go so close to it that you see one more dimension. You see that it as a 3D object. So you just know that it is a 3D object, which once was a zero dimensional object, which was a dot, is now looking as a three-dimensional object, which I think is amazing, because you're just increasing the dimensions as you go closer. So one example that I'll give you is there is an object that is like this. You go into it, again you go into it, and when you go into it, the each grid is turning into more 100 grids. Each grid is turning into more 100 grids, and until you reach into such a microscopic level that you see more dimensions. So like the rod that was there in the traffic signal, which the ant was able to go through, but you saw it as one dimensional thing. So similarly, you are just seeing it as a three-dimensional thing. Maybe if you zoom into it more, into the real world things, if you zoom into the real world things more, you will see more dimensions that are maybe circular or some other shape. So this is the string theory. The string theory talks all about the higher dimensions. So scientists have not yet proven this, but I think if you were a microscopic ant, uh, you could go into such small spaces. So this is an ant here. I don't think you can see it, but here is a black ant in this portion. So she can see more dimensions. So she can see more things in there, more things that are going into there in there. But obviously ants are not so small. There can be more smaller things that can go into quantum scale. If you have seen the movie Ant-Man, so in Ant-Man, the person, the inventor, I don't remember the name, instructed Ant-Man to not to go into the quantum scale or he'll never return. So he was talking about it, because like the alien disappeared, the boxes that were there, you may get disappeared from the quantum scale. You may get into some other dimension. You may get into some other world that is something different from the three-dimensional world that we are used to. So yeah, one more example. There is a candle, and you're just going into the depth of it. You're just going into it. There will be some atoms into it. It is made up of atoms. So this is the nucleus of an atom. Till now, the conventional physicists that have lived so far, they have just gone through the atom, and they have gone through to the stage where they found quarks. So these balls right here are quarks. So there are two types of quarks, up quarks and down quarks. I'll not get into the depth of it, but yeah, uh, there are quarks. But the theoretical physicists and the physicists right now, they are researching more, and they are establishing a new theory called the superstring theory. So by according to this theory, they go into a much closer scale to quarks, and they see that there are some strings, there are some vibrating strings to each quark, and these are not actually quarks. These are the strings that are producing not the musical notes. So there are some strings that produce, the vibrating strings produce musical notes. They are the waves that they produce, the musical notes. But in this case, the waves are said to be the particles. So a glass of water, the same glass of water that I showed day before yesterday, so this glass of water can be made up of strings that are producing particles, So they are producing waves that made up the particles, the quarks, the nucleus, the atoms of this thing right here. And this is the end product of it. So we all are made up of strings. This theory is not yet proven, or it is not yet certified. Some physicists don't believe it, but yes, it is a thing that can be possible, and yeah, it will be. So when physicists just examined the things, and uh, he just they just did the calculations. They found that the world can world if the world works on this theory, the world can exist not in 1, 2, 3, not in 4 dimensions, 5 dimensions, 6 dimensions, but it should actually be 10 dimensions. But if you visualize 10 dimensions, so in the first example that I said, when you add dimensions, you just take 2 pens, 3 pens, and just make it mutually perpendicular. But what if I have 10 dimensions? So that will be a difficult task for me to keep everything mutually perpendicular to each other. So uh, that can be represented in a two-dimensional form or a three-dimensional form. So this is a shape that they have come to, and this is the conclusion of the whole superstring theory. This is a Calabi shape. This is called a Calabi shape, and it has 10 dimensions. So surprisingly, it is not that comprehensible for our brains, but as I said earlier, because we are not that advanced of a species to comprehend higher dimensions. But yeah, this can be possible. So this right here is a Hydron Collider. So I'll just tell you this because I think this is also amazing. So this is a Hadron Collider in Europe. So it is in CERN, which is a nuclear research center in Europe. So they have made this Hadron Collider, which is the fastest accelerator, particle accelerator ever to exist. So what they'll do, they'll just accelerate two particles in this tunnel right here. So in this tunnel, they'll just accelerate two particles with close to the speed of light, and they will make the two particles strike with the enormous speed. And they have done that. So they have found various different objects, the various different particles and various different things. When they went to the site at which the two particles collided, they found various different things that could be a different era for humanity, the a different era of discovery. We are discovering the world which is around us, and we have not yet completed it. So it tells us that there is a lot to explore now. So there were so many particles in it that were not yet known to man. So this is an amazing thing that I think. So yeah, that's pretty much it. If you have any questions, you can put it in the chat box. Like always, this wasn't a scripted lecture. So I had just taken the images from Google an hour ago. So yeah. Yeah, we will stay if you want. 5 minutes past. We started late, I think. Yeah. How can we make a 10D object? We can't actually, but we can make some calculations on how we made. We can just intuitively make a 10D object by how we made a 4D object, because you just have a progression ahead. So uh, you just study the patterns of the universe, and you just guess. It is a game of guessing ahead. So the pattern in the universe of dimensions, it tells us that when you pile up infinitely many things, you get 1 + 1 dimension. So uh, by that way, maybe the physicists and scientists have made this theory, and and made this thing. Is there a study on what happens to you when you die? So there are some theories that say that when you die, or your soul or anything, your consciousness disappears. So it doesn't disappear actually. Maybe it goes into higher dimensions that we are not yet uh, aware of. So yeah, that is a theory. That is not my personal opinion. I think consciousness can be transferred, because I think that that's a futuristic thing. But according to me, that would be a cool thing to happen. There's something called brain uploading. So this is off topic. So this is not a topic that I'm covering. This is just a thing that I think will be helpful for you all, or that I think amazing. So uh, so there is a thing called brain uploading. So you just buy like bionic body parts. You just take the brain of a person and you just upload it to some robot. So you're what you're doing is you're just uploading the consciousness of the person to some other robot or some other creature. So he has the memory of you, he has everything, that he has all the characteristics that you had. So that is you. But I don't think that will be possible in the next 30 years. It will be, maybe it will be possible in the next 100 years. I heard that someone teleported a molecule to space. How did they do it? Yeah, I'm not aware of that, but I'll surely do research on that. If you are, I'll just do some research and I'll just tell it to you in the next lecture. That will be very nice. So yeah, I'll just copy it. And someone asked earlier that how can we access the recordings of the lectures. So I'll just post a link on it, a YouTube link. It is a playlist, all the lectures that have been done on wave 5, in wave 5 of the wave learning festival. The lectures videos can be are uploaded there. So I'll also upload. I haven't yet done that. I'll just do it today, and I'll just post a link on the ed platform. Is that okay? Yeah. So wouldn't you be able to do the same with your brain? Yeah, I'll be able to do that. Or uh, if you see it as a human thing, you can upload it to some other robot. So uh, I don't get your question actually. Wouldn't you be able to do the same with your brain? Uh, this is a very nice question. Thanks, Nick, for asking me. Edwin Hubble said that the universe is expanding. So, if the universe is expanding, that is also the thing that, yeah, we generally take our Earth or our universe, our galaxy as the origin of everything. So we take it as the midpoint of everything, and we just take everything with reference to our Earth as the origin. So um, if the universe is expanding, that is what I said in the earlier class when I said about entropy. So that is a that is an example of what entropy means. So the entropy of the universe is constantly increasing, so it is also expanding. So that's the reason it is increasing. I think the things that you're asking, the devices that your brain can control, or the device that that can control your brain, have already been invented. There are some cathodes or electrodes that you put on your brain, and you just have to do something, and it just reads your brain. It just you can just play games with it. You can just play video games with it, and I think it is done already. I'm not sure about it, but I've heard about it. I'm not that aware of that. But yeah, I think if you see a famous science experiment, there is a science experiment which talks about a man has connected electrodes to his hand, and there is a superficial pulse here. There is a superficial nerve here. Uh, so what is the mechanism by which your hand moves? So the mechanism by which your hand moves is there is some electric pulse that goes from your brain to the hand, and just it tells him to there is some charge that just goes there, and your just hand just contract. So he just connected the electrodes to one superficial nerve that is present here, and that electrodes were connected to another person's hands, and he could move that another person's hand a little bit with his hand moving. So he could control the other person's hand with his brain. So that was something I thought would be cool. I want one of those. Yeah, I too want one of those. Uh, my favorite thing in physics is, yeah, theoretical physics, which talks about the universe. And I think I personally think that there is nothing like there are nothing like branches of physics, chemistry, biology. Everything is connected. So yeah, but you branched them because of the purity of that. So math is pure sciences. So then physics is pure sciences. Then chemistry. Then biology. Yeah. So uh, science is all about what we think of the universe and what we interpret about it. Theoretical physicists, there are physics, there are a lot of books that you can refer. There is a book, uh, the theory of relativity, the special and the general theory. So that is written by that is compiled work of Albert Einstein. So that is a thin book, that is not so thick, so you can just read it. I'll just connect the charger to my laptop. So, if you have any more questions, you can ask. I feel like quantum is study of small, classical physics is study of big, and I feel like biology is the study of middle-sized things. Quantum is the study of small, that is correct. Classical physics is the study of big, not actually big. You can't say big. It is the study of forces and everything. Classical physics, forces and macro things, not big things, but it is the study of forces. So, and I feel like biology, no, biology also deals with small things like cells, but not smaller than that. If you go smaller than that, you have to consult chemistry and physics. So all of that comes in that. So biology just deals with, I think everything is connected, because if you talk about life sciences, which is biology, there is a lot going on in our body. So there is also physics going on. There are also chemical reactions going on in our body. So there is everything going on in life sciences too. And when you talk about physics, physics is pure because it is not dependent on any other thing. So it is just dependent on math. And chemistry, I think, is a branch of physics that has come out recently, which talks about things that are small. And yeah, the basics of all science are physics and maths, because mathematics is also important to learn about science too. Yeah, you can also ping me on Instagram. I don't know if that is okay. So you can drop your Instagram username in the thread, the ed thread. our discussion website that is there. So on the ed thread, I have made a post in which I've told that you can drop your Instagram if you want to get added in the group. So I think Olivia and Charm and Hassan are there in the group. So and two or three more are there. So you can also put your Instagram there or username there. Yeah, that is the conservation of law of conservation of matter. So you can't create matter, nor you can destroy matter. You can just change it from one form to another. I think they can pop out in and out of existence, because I think they just go into higher dimensions, as we talked earlier. Because existence, what you call about existence, is not actually the feeling that you have, you just see it. So existence just is that you see something. Yeah. That makes more dimensions makes sense. When you talk about time travel, you travel through time every day. You travel through time at the rate of 1 second per second. So yeah, so you just travel 24 hours every day. So that is not a thing. The yeah, you travel into the future from the past. So yeah. So if you have any other questions, you can ask, or we can just end it here. I'm not yet aware of the big crunch, but I'll just Google it. And one more question I have to Google and do some research on. Also, I'll just give you one more helpful resource that you can use for your uh, study, which is Google Scholar. If you are not aware of that, you can use that, because that is a trusted resource that you can use, because there are papers that you can use. There are scientific papers, that is a researched work, unlike the normal Google website where anyone can upload anything on the web. But Google Scholar is something that you can use for researching on something. So I'll just ping that in the chat box. I'll just do that. Yeah, I've pinged that, scholar.google.com. Google Scholar, yeah. In the next lecture, I will talk about the main special theory of relativity, in which I'll just start with the two postulates that are famous for the that are popular for the special theory of relativity. And then maybe I'll just tell you one example for that will be a bonus example for the general theory of relativity, that I'll just tell you in brief, so what that means and everything. uh, that It's just one class is left right now. So today was the second last class. It was the second and the second last class. So the last class will be on Saturday, same timing and the same link. Yeah, so it seems you like discussion, Nick. So yeah, I'll try that surely, but I think there is a lot to cover in the last class. I'll just make it, but I'll just try it. I'll just cover the concepts, because you already know the prerequisites to it. Because my idea for the class was not to teach a theory that you can brag about, that I know the theory of special relativity or the special theory of relativity, but my aim for the class was to make you more aware and informative about the world around you. So uh, and to and to and to just make a love for science, just catalyze a love for science. So I just want you to love science, because this the concept that science is based upon everything that is around you, I think that is amazing. So yeah, I someone actually asked me, will you just organize a Kahoot? I was not able to do that. I'll try that in the next class, but I can't assure you, because I think I'm not able to do that. So yeah, meet you on Saturday. Thank you for joining today, and thank you for everything. Yeah, bye.